Hi everybody, this is Chris, and I'd like to thank you for your purchase of a NeoCube, a device which I'm sure will bring you hours of entertainment. Okay, this is the tutorial about lined up versus interlinked, and this is just a simple explanation of the two kinds of bonds you can have in between your spheres, and how that works out for you. Alright, first is just a simple explanation of what's going on here. Each of these spheres is a magnet by itself. But when magnets line up, they're always lining up at their poles, right? So, and they always line up the same way. So if this side, say, is the north side, this side is the south side. And for every single sphere in between, it's the same thing. In this sphere, that side is north, and that side is south. So, lined up versus interlinked, if you have a line, and you fold it so that, remember, this side's north and this side's south, if you fold it so that now you have two lines, this one is still north and this one is still south. They're going opposite ways. They'll be nice and lined up. You see how every sphere in the top line is connected to only one sphere in the bottom line. Now the opposite of this is when the poles are aligned in the same way in both the two. So, to do that, you can wrap it around your finger, and now both of these lines, these two parallel lines, are pointing in the same direction. That is, this one is north, and this one is also north, and both of these two are south. And this has the neat advantage of being able to be pulled out. So if you take one and you just pull on it, it'll just come out into a long line, because remember, all the magnets were pointing in the same direction anyway. On this one, you can't pull it out, but what you can do is flip it over. And there you have it. Now, if you're working with little polygons, this is an example of two small triangles that are obviously having a lined up bond in between them. Now, the opposite of this is when one of these is flipped over, they'll have an interlinked bond. Now, most of the time when you're working with these little polygons, you're going to want to have a lined up bond because it tends to work a lot better. You see how that shape got deformed. Here's an example with two hexagons. Basically the same principle. Here they are lined up, and here they are interlinked. And just to reverse that, all you have to do is flip one over, and there you have it. Now, if you're working with three-dimensional shapes, it's a little bit trickier. Here they are lined up. Now, if you want to get them interlinked, you have to flip one inside out. There they are interlinked. See that? Now, again, you'll normally want them lined up, so you take one and you flip it inside out, just like that, and there you have it. Now, if you have a ring, like this one, see, this ring here is composed of three lines, and they're all lined up, or they're all interlinked rather. To change that, you take one of the rings and you flip it around, and it'll be lined up. So you go to the other side and you just flip it around, and there you go. And that's how you go from lined up to interlinked.